Right, the purpose of this video is to provide you with what will be expected when you make a polynomial graph. In order to provide a detailed graph, not just a sketch of a graph, we want to include all the major parts of a polynomial. So the first couple of things that we would take a look at would be where are the x-intercepts. So given f of x up here at the top, you'll notice that we're already in factored form, which is very helpful. If you're not in factored form, again, you're going to have to use all the methods of the fundamental theorem, how to find zeros on a graph, how to synthetically divide them out, or how to factor that down. However, if you are in factored form, remember that factors provide zeros. Anywhere that one of our factors would be 0, we'll make the entire function 0. So if I plugged in 2 in this first factor, 2 minus 2 provides 0. So my x-intercepts will be at 2, negative 2, according to that second factor, and 7. So I can go on my graph already and provide some accurate points. Out at 2, assuming that I'm counting by ones, I'm going to label that 10 over there, negative 2, and at positive 7, I already know that I've got some accurate zeros. That 1/5 out in front, remember, that can't make it equal to 0 as far as our function is concerned, because I'm not plugging in an x. That's just always 1/5. But if my factors are 0, then I'm taking 0 times everything else, and everything will turn to 0. The second thing that we want to be able to provide are minimums and maximums, or what are sometimes called the extrema of our graph, also called the turning points. Turning points are where our graph turns from going up to going down. Those are what we call turning points. Now, in order to get those, the best thing that we can do is go ahead and hop onto our calculator. Since we don't know calculus, we're going to let our calculator do the work. We want to be able to see those maximums and minimums. So you'll notice that my minimum right now is off my graph. So what I'm going to do is go ahead and change my bottom number here, possibly to negative 10, and get that onto my screen. Again, you can also do that via the menu. Go to Window, Zoom, or Window Setup, and you can set your window settings, or you could change, using the other various zooms on our calculator. But now that I can see my max and my min, just like the way that we find intersection points on a graph, and just like the way we find zeros on a graph, we can just go to Menu, Analyze, and notice we can find the minimums and maximums. So if my minimum is over here at the right, I'm going to go to the left side of that, scroll to the right, and you'll notice that between those two lower and upper bounds, it's just going to provide me with the lowest point between those lines. So the farther I go to the right, that lower point keeps going down, 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 until I pass that minimum, and that is the lowest point between those two lines. So that's why it calls it the minimum. So 4.937 for an x value, 937, comma, remember when you're providing a minimum, provide the entire coordinate point, negative 8.406. Negative 8.406. Technically that y value, negative 8.406, is my minimum value, but a minimum on a graph is actually a coordinate point. So we're going to go over to 4.9 and down to 8.4, and again accurately, or as accurately as we can anyway, plot that point. Let's do the same thing for our maximum. So Menu, Analyze, Maximum. I'm going to go to the left, scroll past, and go to the right, and negative 0.270, negative 0.270, comma, 5.71. Looks like we get a nice round number there. 5.71 gives me a reasonably accurate negative 0.2 and up to 5.7 point. Don't just assume that it's on the axis because it was close to it. We want to be fairly accurate. We're trying to make a nice accurate graph, not a sketch. Now, those points alone are pretty good, and they would provide us a fairly good graph. The next thing we might want to look at is end behavior. Notice that, again, all of these factors are positive. If I FOILed them all together, we've got 1, 2, 3 different x's. So I know I'm looking at a cubic function. So my graph's going to go up and go down in one direction or the other. We also have a positive 1/5 out in front, that positive leading coefficient. So to the right, I know I'm going upwards, and to the left, I'm going downwards, according to my leading coefficient test. All that tells me is that I'm going to go down this direction off of here, and I'm going to go up this direction off of there. Question is how quickly, and where am I going to make the rest of these curves? With that, the next best thing to do is use some table points. So if we go back to our calculator one more time, and we open up our table, right, we can see a large amount of fairly good points there. And if I just scroll to the side here, I don't know that it's going to let me hang on to those. So actually, I'm going to go ahead and take a quick little screenshot here in order to get some points to plot. Now, of course, you could just set your calculator next to your paper and make sure that you can see your points. But I'm then going to go to 0, 5.6, right up next to my other point. So there's not much I can do there. But at 1, I can go to 3.6. At -1, if I go back to my calculator real quick here, if I went up to -1, I could go to 4.8. And as long as we're at it, -3, -10. So at -1, 4.8. And at -3, I'm down at -10. Again, that gives me a good point to go right up through there. Scroll up, come down as accurately as we can. Again, if I can at least see the points, I'm going to assume we're nice and accurate there. And then I can use the points out at 3, -4, 4, -7.2, and 5, -8.4. It's kind of right next to my other point there. Which would be nice to know out at 6 as well what we're going to get. So again, on my calculator, looks like -6.4. But then by the time we reach 8, we're already up at 12. So we'll go to 6, -6.4. And by the time we get to 8, we're all the way up at 12. So we're just going to let that go right off my graph. But do your best to, as smoothly as you can, connect those points. Remember to label your graphs. We know what you counted by. But that provides a very nice sketch. Well labeled, points showing, zeros, max, min, everything is really good on your graph. Remember that the fundamental theorem provided n complex zeros due to having degree n. When we talk about those turning points, those maxes and mins, if your degree is n, we also know that we'll have n minus 1, or you could have up to n minus 1 turning points, maximums and minimums. Go ahead and take this next graph. Try finding all those important parts. Again, start with the x-intercepts, get the max and min, provide the end behavior, and if you need more points, provide more points, and see if you can make an accurate sketch on your page that'll match your calculator. I'll come back with the answer here in just a second. Here's your graph for you. I went ahead and looked at my factors and said that -3 in this factor is going to give me a 0, as well as 1 in this factor. Also notice that that factor is squared, which means that technically that factor counts twice. So when we think about end behavior, technically we have x times a third x. We actually have a cubic function. This will be cubic, as you note from the S-curve you get on the graph. Also, that means that my maximum that occurs at 1, 0 is actually a double 0 as far as that x-intercept is concerned, which is why, again, it bounces off that graph. Double 0 because it was a double factor, x minus 1 squared. Also, we note that -1/2 in front meant that we went from the upper left to the lower right as far as end behavior is concerned. And then I also just went ahead and found my minimum and found some other points on my graph to make that a nice clean sketch. I hope that helps you with graphing polynomials via the TI Inspire and getting lots of details using the table, using maxes, mins, and zeros, and you can make a nice graph. I'll show you a couple examples if you watch the second video from this section on how to apply using a good graph and finding maximums and minimums to different various applications in the real world. Good luck. If you have any questions, ask your teacher, and have a lot of fun.